Have you ever been wondering on how many information about ourselves we're sharing in the conversations with the others or when we're sending them the message, no matter in any other conditions? Well, when we're coming in towards the generative AI, within this talk, I'm going to navigate you to the most recent advances that will help you to understand and answer this question through the application of the machine learning methods. And with all of that, in this video, we're going to cover the following topic, dubbed as reading between the lines, adapting GenAI for implicit information retrieval. So my name is Nikolai Osachenko, and let's dive into the whole presentation through my particular experience in it. But first of all, we're going to start by taking a closer look on what was specifically referred to by saying information retrieval and by overviewing the related domains of studies. So information retrieval represents a part of the so-called natural language processing, where natural language processing is a set of the tasks and studies that aim at deeper understanding of the conversational aspects between the human and the machine. So when we're dealing and interacting with the computers, there are several prospects in which the computers or machine tend to understand our requests or our language. And all of that results in a series of the tasks. So one of them could be referred to as the machine translation, text summarization, text simplification, question answering, and all of that related as the open-end problems. However, there are another type of areas that is so-called the closed-end responses, problems that involves answering on particular questions related to information that we're sharing. So, for example, it might be classification of the text. It might be extraction of the objects that were mentioned. And on all of that is where we could be classified as the area of the information retrieval, when we wish to extract something out of the communication that we are dealing with the machine. So, and among the types of information that are related to this area as information retrieval, there are such type of information that could be accessible straight away, that we refer to as the explicit one. While, and on the other hand, there is another type that is kind of takes more efforts in order to retrieve this. And with all of that, I'm referring to a so-called implicit information retrieval. So within this presentation, we're gonna give the definition for the implicit information retrieval as such information that is in a hidden way associated with the author of the text, with the person, if we're dealing with the conversations and the dialogues, or a character, for example, speaking of books, or it could be also be a patient if we're dealing with the medical text. So, and with all the cases, depending on each text in particular, we tend to associate such an information with the particular owner. And with that, we mean implicit information retrieval. Let me give you a quick example of what was specifically referring to it, just out of the context of the natural language processing and machine learning area. Imagine in the case when you are meeting the person you are know for a while. So the first phrase that you can go with, you say, how are you? What would be the first observations that we can get out of this line? So, and they are, as you can show, as follows. It could, first of all, it's an open-end question. Apparently, there are no aspects of interest in that person. And let's say if we are in the domain of the dating, we can also convey that we are likely asking for the attention of the person. While on another hand is that just to notice on how this would change if we go with another line, which is, hey, what would be the nice person? So the main observations out of this line would be as follows, is that first of all, it's a closed-end question, which is actually end up being a simple response. Second one, we showcase the interest in the person through the mentioned word nice. And we also sharing information about the emotions. First of all, emotion states of our one, which could be conveyed as a joy, as well as the emotion that we're going to cause in a person, which tend to be likely joy either. So, but independent of each of these individual cases in particular, it is purely a good example of how much information about ourselves we can reveal within these two individual lines in particular. Now let's take a closer look on what would be the science prospect sayings on this one and actual directions in which we're going to cover implicit information retrieval within the coming presentation, and alongside with that, overview on what would be the studies in it. So the first domain that covers this prospect is a so-called sentiment analysis. So sentiment analysis is a task that is aimed at extraction of the author opinions towards the objects mentioned in text. And one example is showcased on a slide where you can see the complexity of the related problem, because among the list of the mentioned objects within a given example on the slide, it's possible to see that only for the several objects, author actually shares his opinion in the text. And besides sentiment analysis, another problem is the so-called emotion causes extraction, or emotion states recognition, where back in the beginning of this year, so SemiWall 2024, where the related problem was emphasized through the dataset of the conversations, for example, as a Friends TV show. So the problem is that given the conversation with a numerous set of characters, is to find out which utterances and how they affect on the others from the prospect of the caused emotions. So with this particular part, I'm referring to the textual modality, while the actual task itself exists with the various of them, including the audio and, of course, the video. Okay, so then you may ask me, like, once we gave all these introductions, what will be the takeaway from the rest of the video? So, and they are actually threefold. So first of all, we showcase the key advantages of the AI that lead to the generative AI. Secondly, we emphasize on what will be the steps for mastering your GenAI application for the implicit information retrieval. And finally, I'm showcasing you the quick starting tips that may help you to dealing with your implicit information retrieval problems, especially if you have such a data sources such as CSV, JSON-lines, and SQLite databases, so that you can quickly start to apply all the techniques that were mentioned out there straight out of this video. Without further ado, let's move on to the first part, which navigates us to the generative AI advances that lead us to the appearance of so-called large language models and the AI we have nowadays. I decided to outline and separate the related advances in the two individual directions that lead to appearance of large language models. So they are as follows. So the first one, we will review the architectural aspects, and the second one will be related to the data-related one. So speaking about the architectural aspects, if we come towards 2013, which was nearly 12 years ago, is the time when the neural networks finds their application at its best and finally could beat the conventional methods that were in use before. And with all of that, I'm referring to the two main architectures that are become very well distributed since that time. So the first one is the so-called convolutional neural networks, and the second one refers us to recurrent neural networks. So speaking about the convolutional neural networks, they are finding initial application from the image processing. However, and in order to adapt them for the text, it is quite important to treat the text in order to have a similar representation in the form of the vectors. So where each individual token represents a vector. So the conceptually is the approach where we have a sliding window, and using the different filters, we have a different representations of our input. While on the other hand, dealing again with the vectors in the input context, recurrent neural networks are attempted to this problem from another prospect where we have a one state, and through this state, we sequentially pass the input information. So here is, I'm deliberately refer to the recurrent neural networks as they are become a part of the further advances that are become hugely distributed in such a domain as the machine translation. So in the machine translation is a problem of with the open-end answers where we just generating the output text in another language. And with all that, such an architecture as encoder-decoder represents another milestone that become majorly distributed onto the other fields besides the machine transaction itself. However, it has, despite its advances, it has a huge limitation that falls onto the encoder vector that connects encoder and encoder parts. So the major problem is that the huge payload falls on this vector depending on the size of the input. And in order to cope with that problem and filter the most relevant information out of it is where the attention mechanism finds its application, and with the result architecture dubbed as transformers. So simply speaking, what are the transformers? So transformers is actually encoder-decoder architectures that involves attention mechanisms alongside with the concept of heads. So heads we can treat as just individual so-called instances of the encoder-encoder architectures alongside aimed at the overall robustness of the system. Speaking about the attention mechanism, I decided to go with this slide to showcase the actual examples on what we specifically can visually see how the important information is filtered. So the key concept of attention is kind of weighting of the context. And within the transformer architecture, this weighting can happen on the different layers. That's a showcase from the left to the right. That means from the bottom to the upper. The quick observation from my experience in this particular area is that depending on the layer, such a behavior of the weighting might differ, is how we can also understanding information different ways. So for example, on the deeper layers, we have a strict connection for the particular words that lead us to the most important part of the sentence, while on the upper layers, we kind of gather all the information out of it. So this is just one particular example in the area of sentiment analysis and how we can observe this behavior. But in general, attention is present a huge milestone that lead us in the appearance of language models. Towards the data-related prospects, it is worth to showcase the three major important steps that were made. And besides the supervised tuning that was known for ages and still is quite important for the developing domain-oriented systems, it is worth to showcase that unsupervised pre-training were a huge part of the models even before the transformers area. The reason is how, due to the relatively complexity and the spending amount of efforts and manual annotation of the data, is quite important that we can go with the non-annotated text or adopt a so-called distance supervision techniques in order to automatically annotate it with the minimum noise. However, and despite the related advances that lead us to models, the next crucial step was related to the supervised tuning with the instructions. So by saying instructions, I'm referring to the set of the tasks that alongside with the definition of a problem serves with the relay with the expected response. So you can treat it as the question answering problems that were used in order to fine tune the model. And once it's there, the very teeny part on the top is that makes us towards the chat related systems that remember the history, is where we have to have the human related response or feedback, is what also navigate us to the several advances that were made on how specifically we can train by relying on the human feedback. Is where one way is to go with it is the reinforcement learning with the human feedback. Combining all these things together, so data prospects and the model prospects, is how we can get to so-called large language models that represents transformers with the instruction tuning and optional reinforcement learning with the human feedback. Okay, once we are decided with the architectural aspects that are leads to GenAI, now let's take a look at how specifically we can mastering the implicit information retrieval being in this area. And starting with this, let me first emphasize quickly for the tasks that were already showcased in the introduction, which data that we specifically have for each task individually. Speaking about sentiment analysis, we go with the recently 2023 data set that represents text written in Russian, and for each sentence, these are sentences for mass media analytical articles that has one of the three classes, so it will be positive, negative, or neutral, where you have to extract opinion towards the objects mentioned in text. While on the other hand, we also experiment with the emotion causes extraction from the related data set that represents conversations from the Friends TV show. These texts were written in English, and all the sentences, they classified up to one of the 7 dialogues, the conversations, especially connections from one address to the other, alongside with the artificially invented class, which is a neutral one. So given all this information, then you may ask on how specifically we can perform the evaluation and measure the advance of the models that we experiment with. So here's where F-measure actually finds its application. So F-measure is the combination of the 2 other fundamental measures that were used for each class individually. And with all that, I am emphasizing the precision and recall. So the precision is how many retrieved items are relevant, while the recall refers to how many relevant items are retrieved. So measuring all that for each class individually and then combining together is how we can assess the models. And then towards the initial experiments is how you can say, what if we just experiment straight away is what we actually decided to go at first. So given our large language models, or for example, a ChatGPT system, we can simply prompt it in order to obtain a response. So once we try out, now let's take a look on what was our key takeaways that we can get out of it. So the first key takeaway was when we're using this, especially for the sentiment analysis problem, when the texts were initially written in English text, we found that it is quite crucial to perform text translation. On the following slide, you can see the bars that are green in color relate to original text, which was Russian, and bars that are in purple color, they're related to the text that were automatically translated in English. So according to the results across all the models, you can see that the actual improvements pretty much varies depending on each model individually. However, in general, it's possible to see the strong benefit of text that were translated in English. So to conclude, it's quite important to translate your text in English if you wish to expect a better reasoning. Secondly, as this actually goes from the following concept of the bias that you may experience with your data set, that bias in between the mentioned entities and their names and labels provided for each individual record of the data set. So to cope with that bias, the empirical example goes from one paper that was submitted and reached the high scores on the related competitions for the sentiment analysis, where author, alongside with it, experiment with the masking entities to cope with the related bias caused in the data set. And through their studies, they showcase that the benefit would be in between 1 up to 4%. So combining all of this together, I would say that it's quite crucial to adopt, if you have a chance, the entities masking within your text processing pipeline. So combining all of this together, that is how updates our main diagram of the system. So it's crucial to go with the pre-processing with 2 emphasized steps of masking named entities and performing the translation if the texts are not written in English. Okay, so finally, let's move on to the advances that you tend to make in terms of the large language models that may more closer focused on the implicit information retrieval. And speaking about the reasoning, one of the area where the reasoning finds its usual application is the common sense reasoning problems. So these are tasks in which you are actually can organize such a thinking of in so-called steps that are lead from the initial definition up to the very answer of your problem. The initial issues that we have when we're dealing with large language models, so-called hallucinations, is where for the given input, we have a different output that could be properly explained, but the whole explanation is not correct. So the concept here is that when we just passing the common sense reasoning problem straight away, it is very likely that in several cases we end up going the wrong response. However, and in the common sense reasoning task, we ask the model to split it into individual steps so that model can rely on every single time on the steps that were initially generated. It technically leads to the better results. It's what showcased in the related studies, but the key takeaway is that it is still better within such conditions to go with reasoning step by step in order to get the results. However, and that becomes a point, is that you may ask me, is like, Nikolai, how we can adopt this into the implicit information retrieval? So like, what will be the steps? Because here in the common sense reasoning, it makes sense that we have individual steps that relate to something, but what will be the steps or in intermediate part that we can rely on in the implicit information retrieval? So among all of the various approaches I believe might exist in this area, so one of them that finds a huge application being proposed, the one year ago at the ACM conference, where they emphasize that such a chain could be organized in 3 major steps. So with that, I'm referring to the 3 main concepts that could be used to retrieve this result. The first one is to find out the aspect in the text which we can rely on, obtain the opinion that is reliant on it, and finally perform the retrieving. To simply understand, to bring an attempt on understanding this, is how I can refer to the actual novel book that has no any alignment with these particular studies and the concept of reasoning, but actually focused on the methods of the rationality, where, and unlike the character that originates from original series of books, and the main character in this book is quite smart enough by the very beginning, and every single time when they cope with the problems, he go with the rationality laws. And among the list of the various of these laws, he used to refer to the first rationality law, where on page 682, we can read the following line, which is actually first time when it showcases the first law of the rationality. So Harry Potter actually goes with, by asking fundamental question of rationality. We can put up the first question, but because the second one is actually way more important. And it goes, what do you think you know, and how do you think you know it? So if we demarcate these sentences into 2 main crucial parts, where the first one is, what do you think you know, is actually refers us to the factual knowledge that we have, is what mimics to the aspect. And the second part is, how do you think you know it? Is basically an opinion on top of the factual information. So through all of that, as you can see, Harry Potter method of rationality actually involves the first law of the rationality that aligns with kind of a chain that is proposed in this paper that involves the aspect and opinion on it. So, and finally, we're also adding the retrieval part. Let's take a closer look on how specifically authors achieve that and what they propose in the form of the so-called 3-hop reasoning concept. So the first step involves providing a sentence and asking for specific aspect towards the entity is mentioned. So once we get a response, we augment this response in the form of the second request with information such as, based on the common sense, was the implicit opinion towards the mentioned aspect, entity, and why. Once we get this, we finally performing the thinking about it. So based on the opinion, what's the sentiment polarity towards the entity? Yeah, in particular, authors go with the sentiment analysis problem, but in my particular experience, this is the case where such a chain could be adopted in the various problems in implicit information retrieval, so we can simply replace it with emotions or anything else. And once it's there, so this is how the whole pipeline of the reasoning, including the pre-processing stages and now with the updated reasoning, can look like, where in the case of the chain, we go with the aspect, opinion, and think steps that we just overview. It is worth here to say is that we can use this in the form of the out of the box, is where we can see this snowflake which showcase that the model is in the initial state. However, we can also improve our results by going with the so-called tuned models. And even better is that we can exploit this concept for the tuning. Within upcoming slides, we're showcasing the related advances that were made with the FLAN T5 models that are less smaller in size, but are capable for the related experiments. And finally, speaking about the experiments, among the tasks that were proposed, I decided to organize and align the advances that were made in the similarly structured tables. So first of all, we experiment with the zero-shot approach like straight away. Secondly, we adopt the fine-tuning, which is like a prompt-based one without the complex reasoning. And the third one was we go with this concept of 3 steps that emphasize as chain of thought. And starting with the emotion extraction, so what will be the key takeaway out there? First of all, there's a huge difference when you go with the zero-shot approach comparing with the models that were fine-tuned. So it's quite crucial here, I would say, in such a task, is actually adapt your models for your particular needs. And speaking more is that once you go with the 3-hop reasoning concept, it gives you extra 2% of the F measure. Towards sentiment analysis, however, it is worth to see that there is not such a big gap in between the zero-shot and the fine-tuning models. But of course, if you wish to have better performance, it is important to go with the fine-tuned models. And especially, we also in our separate studies showcase that once it's done with the 3-hop reasoning concept, you can get even better results. Okay, so once it's there, the whole concept on the pipeline is there. Let's take a look on how specifically we can quickly start and which would be the options to performing the steps that were mentioned in this pipeline with your own models. So the first concept and the first project that I would like to emphasize is so-called bulk-ner, especially if you have a CSV data with lots of the text in which you have to annotate entities. This would be the quickest start in how you can do this, because out of the box we have the framework that is represent like a third part of the related app, which can be switched to another suitable for your needs. But this is how you can perform the annotation and have the JSON files on the end with the mentioned objects in it. And towards the actual large language model part is where you can, I can recommend the project I'm personally working on and exploit in my studies is the bulk chain. So bulk chain allows you actually to save the time and money, especially if you are working with the accessible models of the huge size. Because the common problem that used to happening in this case is that you may lost your progress because of the connection and then start all over again, or just spending a lot of time by messing with the data, by saving the existing data and obtaining the new one. So to cope with all of these problems, this is where the bulk chain comes, and it supports the input data to your easy access. For example, if you have a CSV file with the related textual data and input, all you have to do is just alongside with it provide a schema of the prompts, which is basically a list of the prompts that organize a so-called chain or concept chain of thought. So with all of that, you can perform the related annotation by using the LLM and a so-called complement the CSV with the related columns, and you have a CSV as the output of the related system. So with all that, let me finally emphasize the conclusions that we can get out of this talk. So there are 3 major takeaways that you can get out of it. So first of all, you got the main importance of the implicit information retrieval application from the text or information you can actually get is pretty much diverse, especially with GenAI can extract a lot. Secondly is how you can specifically master your GenAI is where we emphasize that masking entities performing text translation, especially if text not in English, is quite important, and adapting the chain of thought techniques for mastering your reasoning is quite important, where the fine-tuning gets at its best. And finally, you got tips on how you can straight away start with doing these things by applying it to your data written in CSV or JSON files. And that was me. So thank you very much for your attention. Thanks for watching this video.